Consider the function here. A function is given. Find the intervals where f is increasing or decreasing. Also find the local maxima and minima. Okay, maximum values and minimum values with corresponding coordinates. So the function is given here. 5x raised to 1/3 minus x raised to 5/3. To find where it is increasing or decreasing, we need to use the first derivative test. That means let's find the critical numbers or first derivative. Then first derivative. By the way, what is the domain of this function? Say x raised to power, another x raised to power. I mean, there is no fraction. That means all real numbers. So negative infinity through positive infinity, all real numbers. Okay, let's find the derivative. So power rule. So 5x 1/3 means 1/3 x 1/3 minus 1, negative 2/3 minus 5/3 x 5/3 minus 1, 2/3. So let me simplify this. This is 5/3. Oh, that's negative exponent. So let's put that on the bottom. X raised to 2/3. Okay, minus this is 5/3. It's positive x to the 2/3. That's on the top. I mean, when I write in this way, this is on the top. Okay, that's the derivative. To find the critical numbers or critical points, we set the derivative 0. We set the derivative 0. That means this fraction equals 0. I mean, this whole thing is equal to 0. So 5/3 x raised to 2/3 minus 5x raised to 2/3, that's on the top, in fact, over 3. This equals 0. Okay. Now we can combine these two fraction, or we can move this over. Okay, and 5/3, 5/3, we can factor 5/3 out. So if we want to combine, then we have to make common denominator. So let me move this over, because since we have only two terms, we can we can solve in this way. So 5/3 x raised to 2/3 in the left hand side is equal to, move this over means add this fraction to the both sides. So we get 5/3 x raised to 2/3 on the top. Okay, let's cross multiply. That means 5 times 3, 15 equals 3 times 5, 15. So in fact, 15 in the left hand side, 15 in the right hand side, we can cancel 5, 5, 3, 3. Because if we multiply, we're going to get 15 equals 15 something. So here, this is 1 equals something. Let me multiply this way. X raised to 2/3 times x raised to 2/3, that's x raised to 4/3. Okay, multiply means we add the exponents. So x raised to 4/3 is equal to 1. So in fact 15, but we cancel 15. Okay, so x raised to 4/3 equals 1. That means x equals what? Then now we need to solve for x. To solve, look, it's 4/3 means it's a cube root. X fourth times 1/3 cube root. So let's cube both sides first. Cube both sides, then 4/3 times 3, 3 cancel. So we get x raised to 4 equals 1 cube means just 1. So we have x to the 4th equals 1. So this x equals 1. That's not the only x value. Okay, so we need to do some more. Subtract 1 from both sides, we get x to the 4th minus 1 equals 0. Now we can factor x to the 4th minus 1, which is x to the 4th is x square minus 1 squared. So we're going to use difference of two squares, u minus b, u plus v. Okay, so x square is square, so x square minus 1, x square plus 1 equals 0. This does not factor anymore, but this factors. X square minus 1 is x minus 1, x plus 1. Difference of squares one more time. X square plus 1 equals 0. So from this we get 1, from x equals -1, this is never 0. So 1 and -1 are two critical numbers. Okay, but if we look at this derivative, okay, this derivative is undefined when x equals 0. So this is undefined at x equals 0, because 0 on the bottom means we are dividing by 0. Okay, so this is undefined, and 0 is in the domain of the function. The function is here and domain was all real numbers, so this 0 is also a critical number. Okay, remember the definition of critical number. Okay, critical numbers are those numbers where the derivative is 0 or derivative is undefined, and those numbers should be in the domain in the first place anyways. So this is derivative is undefined at 0, that means 0 is a critical number, and when we set the derivative 0 and do all the work here, we got two numbers. So thus the critical numbers or critical points, x equals 0, -1 and 1. Now the question is, we are trying to look where the function is increasing, decreasing. So we need to do the interval test or sign chart. The domain of the function was all real numbers. Now we found three critical numbers: 0, -1 and +1. So we need to test four intervals: -∞ through -1, -1 through 0, and so on. So we pick a representative from each interval and plug that into the derivative. Okay, so we plug that into the derivative, f prime, and when the derivative is positive, the function will be increasing, and so on. So what is the derivative, by the way? 5/3 x raised to 2/3 minus 5/3 x raised to 2/3. So let me write over here. So the derivative is 5/3 x 2/3 minus 5/3, that's the x 2/3 on the top. Okay, now let's pick a representative from each interval. So -∞ through -1, we can pick -2 here, -1/2 here, +1/2 here, 2 here. Okay, and let's plug these numbers into this derivative to see whether it is positive or negative. Use your calculator, plug this in, -2 here for x, then the sign of f prime, you will get a negative number. So I'm going to put negative here, okay, negative. So f prime is negative in this interval, that means the function is decreasing. Plug in -1/2 for x, okay, just plug in -1/2 here, and work in your calculator, you get plus sign. So the positive number, that means derivative is positive, means the function is increasing. Plug in 1/2 here, you get positive again, so it will be increasing. Plug in 2, you get a negative number, that means function is decreasing. Okay, so thus the given function is increasing on here and here. So -1 through 0 and 0 through 1. So we can say -1 through 1, or you can write two intervals, and decreasing on two separate intervals, -∞ through -1, and so plus means this is the union for set, plus 1 through all the way. Okay, and we want to find where the local maximum and minimum. So local maxima, that means look at here. Okay, at 1, what is happening? It's increasing before 1, and after 1 it's decreasing. The function is going up and down, so local maximum occurs at 1, and to find the corresponding value we go back to the function and plug in there. So we'll do that in a moment. And local minimum or minima at -1, so it's going down and up, so -1 and corresponding value. These are the locations for local maximum minimum, and we plug these into the function and we find the corresponding y values. Okay, let's look at the function. So here is the function. I copied down here. So local maximum value at 1, plug in 1 there. So 5 times 1 raised to 1/3, 5 minus 1. So this will be 4, or you can use your calculator. -1. So 5 times this will be -1. -5 minus this will be -1 as well. So -5 plus 1, -4. Oh, these are symmetric kind of. Okay, final.